everybody. It's Miss Rose. I want to teach you a little bit about transformations, which are ways to take points or objects or shapes in mathematics and change them in some sort of way. Throughout the year, we're going to be learning about translations, reflections, rotations, and dilations. So let's start first talking about translations, which is just a fancy math way of talking about shifting things. So you'll see what I mean in a second. First, it says to plot the point -5, 3, and call it A. It says, what quadrant is that point in? So let's refresh our memory about quadrants. The top right, where everything is positive, is quadrant 1, and then go counterclockwise. So which quadrant is point A in? It is in quadrant 2. All right, we are going to translate A, which means to shift it, according to a mathematical rule. If I said this in words, I guarantee nobody would have any issue doing it. The symbols are a little bit intimidating at first, but they actually do make sense. So since it says x plus 5, it means we're going to be moving 5 in the x direction, which means we're going to be moving right 5. And then it says y minus 7, which means we're going to be moving -7 in the y direction, which means we're going to move down 7. So I'm going to take my point A. I'm going to go to the right 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6, 7. And it says to name the image A prime. It's not in a quadrant. It's on the y-axis. And finally, this is a little preview for what we're going to be doing in the weeks to come. It says, can you write an equation for the line that passes through A and A prime? Well, I have a little trick for you. I don't really have to recalculate the slope because I know that we just went right 5 and down 7. So I know that my rise is -7 and my run is 5. And then I also know that A prime is at the point 0, 4, which is the y-intercept. So for the slope, I have -7 over 5. And for the y-intercept, it's at 0, -4. So if I use our old y equals mx plus b formula, I can just go y equals m for slope and b for y-intercept. And that is the equation of my line. All right, here's problem number 2. It's a little bit of a working backwards problem. So let's plot the point 7, 4. This time, did you notice we're not naming it B, we're actually naming it B prime. So that's the image of a point that started somewhere else. It's in quadrant 1 where everything is positive. And then yesterday, Mr. Kim had the original point B, and he shifted it according to this rule to end up at the point B prime that we just plotted. So keep in mind, I am not telling you to shift it right 4 and up 6. I'm telling you that he shifted a different point right 4 and up 6 to get to B prime. So we actually need to work backwards. If we go left 4 and down 6, that should get us at our original B. What I do is I just make sure and check that if I go from B to B prime, make sure that you can count right 4 and up 6. The coordinates of B are 3 over to the right, 3 and down 2. So 3, -2. So maybe I'll make a little note on this that we should be working backwards. All right, finally, our last problem is going to be a little preview about the next transformation that we're going to learn about. So plot the point 8, -7. Name it C. It's in the 4th quadrant. And then it says to use this rule where we take the opposite of the x, but keep the y the same. So it was +8, -7. When we take the opposite of the x, we're just going to go over to -8, -7. And that will be C prime. That's over in the 3rd quadrant. Next, it says, what's the length of the line segment that goes from C prime to C? So there's a quick way to do it, and there's a slower way. I could actually count all the boxes, but I actually know that both of those points are 8 away from the y-axis. So I could go 8 plus 8 is 16 units long. So if I wanted to write a rule for the translation, this is the notation that we write in. We write x comma y maps to, and then the x to go from C to C prime went over to the left 16 units, but the y stayed the same. So we were able to rewrite this transformation using notation that represented a reflection or using notation that represented a translation. Let me know what your questions are, and we'll keep practicing our transformations.